Good morning, everyone. Welcome to today's Autodesk Virtual Academy, brought to you by KETIV Technologies. I'm Nigel Mbayak, application engineer here at KETIV, and your host for today. Really excited. Today's going to be great. I just want to go over a couple of things before we get started. If you do have any questions or comments at any time, please feel free to include them. Type them out in the GoToWebinar chat at the bottom of your screen, and we'll definitely be available to address those when applicable or at the dedicated Q&A session at the end. Today I'm not alone. I'm joined by James Herzing. Hi James, how's it going?
Wonderful, thanks.
So James here, if you can read on the screen here, he is a product marketing manager at Autodesk. I think he's hiding a second alias though. My understanding is that James is a super mega simulation expert, but you know, he just calls himself a simulation expert. But that's just what we'll go with then. So today we're going over the future of making things with simulation. So if you don't kind of understand already what that is you know, looking at the world around us, everything's constantly evolving and changing. Product capabilities are increasing, and things you couldn't possibly do 10 years ago, possible now. And even things that we can't do today are definitely going to be possible in the future with the increase in technology, processing speed, etc. So James is going to go over a couple of those high-level topics. If you're here for like the clicks and the picks and how to set up sims and do that, this might not be the webcast for you. If that's something you want to see, definitely let us know, and we can go over how to actually set up sims, run them, and make sure you validate your product design. Perfect. So what I'll do now is I'll go ahead and pass it on to James, and we'll get the ball rolling. So.
All right, great. Thanks a lot. So, as you just heard, my name is James Herzing. I am a product marketing manager here at Autodesk for the Autodesk Simulation portfolio. I have actually used the software for an unfortunately long time, though, so technical questions should still be okay to ask. This is the future of making things with simulation, so how does the Autodesk Simulation portfolio play into the future of making things? So a quick agenda. Hey, and there's a picture of me. I'm also known as the best-looking simulation engineer, but that's kind of like being the fastest turtle, so not real impressive. All right, today we're going to be looking at a quick introduction and social media, which is becoming near and dear to my heart, and one of the ways that it's most easy for you to get in touch with us. Future of making things with simulation, and how does that help you? Because that's really what it comes down to. We're going to look at some new simulation solutions, and as mentioned, we're going to have some time for questions and answers. If there are any questions that come up after the webinar that you think of, feel free to email me at james.herzing@autodesk.com. All right, so there are the simulation social media channels that we are going to care about today. Easy to find us on Facebook and on Twitter. Instagram, I guess if you like pictures, you could go there. LinkedIn typically has more blog post, white paper type content. And of course, YouTube is a great place to go for all picks and clicks how-to videos to learn how to use your software. Maybe you can watch this on YouTube later to get all of these links. But I would suggest following all of these channels so you can get all sorts of great simulation and engineering content brought to you by yours truly. All right, so the future of making things with simulation. It seems like a pretty broad topic, and it is, but we have a short video here that we can kick off to try and give you an idea of some of the simulation involved and some of the, let's say, software that we can use to make it happen. So let's go ahead and play that video.
The future of making things presents an exciting opportunity to serve customers in ways never thought possible before. All new technologies, materials, operating environments, ecosystems, and manufacturing processes will need to be considered. An essential part of this change will be to enable companies to evaluate new ideas more quickly and flexibly than they do today, making the use of early and iterative simulation, whether from your desktop or the cloud, more crucial than ever. For this reason, as well as meeting customer demand and developing better products, our simulation products will improve molding, additive manufacturing processes, and overall product performance, resulting in increased innovation capacity and reduced warranty issues. Not only that, but by offering a proven technology with reliable and flexible offerings for designers, engineers, and analysts, Autodesk Simulation will allow you to both embrace innovation and implement design processes to differentiate, predict, validate, and optimize product performance, and ultimately deliver cost-effective products to customers faster. With Autodesk's extensive portfolio of simulation products, the future of making things is now.
All right, perfect. Hopefully you all enjoyed that masterpiece of a video. Whoever was involved with that one did a great job. But what you did see there is a number of the technologies, both new and old, that Autodesk is working with respect to simulation for product design. So you still have your mechanical stress, your CFD, your plastic injection molding, but you're also seeing that we have a lot of additive and subtractive manufacturing simulation solutions coming your way as well. So all of these things are going to be topics that we discuss today. But before we do that, we're going to look at possibly the busiest slide I have ever seen. And this is our idea of the future of making things. So, as you can see across the bottom, the traditional product life cycle. And this is all well and good, but we see and envision a bigger and better way for people to design products and get them to market. So traditionally, you have a concept or somebody's drawing their idea out on a napkin. They go ahead and design that in, I don't know, Fusion or Inventor or some other CAD package that I'm not going to mention, and then it goes off to production. Now, wedged in there somewhere, not in the big words, would be where typically people would use simulation to analyze their product and ensure that it's going to work properly and safely. Now, that might not be the best solution, but it's better than nothing. At least you're doing some sort of analysis work to ensure that your part is going to behave properly. So after you simulate, you send it to production, you sell it, and then somebody buys it and uses it. Well, in the new world of the future of making things, we add a lot more to that. So instead of just drawing something out on a napkin, you're looking to make it more configurable. You're looking to make it more personal for the person using it. Changing colors, making it larger, making it more powerful, all up front in the early concept and design phase. Then in the design area, it's not that you're just a CAD guy sitting alone trying to design something and then kicking it off to the analyst. You're collaboratively working with people using Autodesk 360 or other products like apparently in the picture, VR, where you can take a closer look at the products, modify them as you're designing it, having different people work on the different parts and review them all in an interactive environment. Fortunately for us, this also includes simulation, so that you're simulating earlier and more often in the design cycle so that you can avoid failures in your design and make products better before they get to production. Of course, you'll still have that final analyst analysis where they take a look at the final product and put it through the final tests, but this should reduce the number of physical prototypes that you're creating, as well as give you a more reliable product to produce. So we're also changing the way that's being done with such things as industrial additive manufacturing. The experience for the customer is also being improved because everything's connected to the cloud and we know what's going on in the world of social media. We have more ways to interact with them. Some products have this built straight into them. At least we can talk about them, if nothing else, online. And then the connected services. This is pretty amazing the way things work now. Wendy's can track their refrigerators and see if the temperature ever got too high, which might have contaminated their meat. You can lose your iPhone and use your iPad to find it. Everything's going to be connected to the cloud soon, and we want to be part of this journey for you to make your products work that way as well. So where do you use all of this? So another really fancy slide here, but there are a number of places that we see that anybody who is making things in the future is going to or need our help. So improve product performance, win more bids, solving complex machining, improving your yield, enabling closed-loop designs, predictive maintenance. All of these things are things that you probably have to deal with on a daily basis when you're making a new design. And all of these fall into three categories that we're trying to line our software up with: design, make, and use. So if you're designing something, we have the tools for you. If you make it, maybe you're going to be using some of our CNC software. If you use it, maybe it's Fusion Connect that you're working with. All of these things play together nicely so that they help you out. With respect to simulation, though, one topic really is near and dear to my heart, and that's reducing warranty issues. This is a spot where simulation can really help out. And so there are a number of reasons that somebody might get a lot of warranty issues, and most of those are pretty easily avoidable with some upfront work. So first, inadequate designs. I guess I'll put these all up there for you to look at while I talk about them. Improper material selection, lack of testing, and specifying incorrect parts. So let's talk about inadequate design. If you're just designing something in a vacuum in your CAD package, you probably create it and then send it off to be produced. Maybe there's some simulation in there, maybe not. But if you haven't done this, perhaps the walls of your the walls of your part are too thin. What if the part gets dropped and it cracks? What if there's too much vibration going on and you don't have enough life cycles, and your part fails due to fatigue? All of those things can be avoided with the use of simulation. Improper material selection is a perfect case for simulation use, especially when we're using the cloud and being able to analyze, we'll say, nearly endless scenarios for your product. You could choose 50 materials, find the one that is the least expensive for you, that still fits any failure criteria, and have those all analyzed simultaneously, giving you the best option for you to save money, as well as for the end user to be satisfied with the product. Lack of testing or data is another simulation solution where right now maybe you aren't doing enough simulation and you don't know all the ways that the part might fail. You might not be looking at thermal loading, or you might not be looking at vibration. But with this simultaneous cloud analysis, it's easy to run all of these scenarios so that your part can avoid any unfortunate failures, we'll say. Last, specifying incorrect parts. Don't really see how that factors into sim, but it certainly would be a warranty issue. Another big area that simulation helps out is improving product performance. And this can be done in any number of areas, but I'm going to point out three in particular. First, electronics cooling. And as you can see in the image over to the right, we have a picture of the Ember 3D printer that Autodesk put together. So one of the big concerns there is making sure that it's kept at the proper temperature. When you're heating stuff up to solidify it, obviously there's going to be high temperatures involved. There's a lot of fans placed in there, and there's a lot of design that goes into that. My favorite example of where electronics cooling probably should have been investigated a little bit more is in the Xbox. Does anybody remember the red ring of death? I know that I do because I had that happen. And unfortunately, I think that there was a little bit of miscalculation in the amount of cooling going on in the Xbox, and it led to a little bit of overheating. So maybe Microsoft should buy a few more seats of CFD. Mechanical failure. So this could be your typical loading or unloading of your part, where something is becoming nonlinear and your part's going to permanently deform. Or maybe this is taking a look at life cycle or fatigue cycles, so that if your part flexes too many times, it fails because of vibrations. All of these can be looked at and are applicable to pretty much any big machine, anything that has a motor, anything that could be dropped, all sorts of mechanical failures possible. Another example is thermal expansion. So if parts are moving, they tend to get hot. If parts are moving and touching something else, like brakes or anything of that sort, they're going to get even hotter. When things get hot, they tend to expand. And when they expand, they can unfortunately touch other parts of the design that they weren't intended to be in contact with. If that happens, you can see wearing, you can see warping, all sorts of problems that might not be thought of when the part's being designed. If you're using simulation early in your design cycle, though, you can make sure that you account for that sort of expansion so that your parts aren't coming in contact with each other. Another great way that simulation can be used for the future of making things is increasing innovation. So right here we have an image of a nest. Now I don't have one of these, but my boss does, and he seems to be pretty thrilled with this. So if you don't know what this is, it's basically a fancy thermostat for your house, where I can then control all of the temperatures of every room in my house individually. If I'm in there, maybe it'll keep it warmer. If I don't use the room much, we can keep it colder. Anything along those needs. So that's kind of interesting innovation, but something that I think is a little closer to what we're looking for would be something like shape generator. So inside of Autodesk Inventor, we have this cool new technology called shape generator, which is going to give you the best possible design, do it quickly, and give you more time to innovate on your creation. So if you don't know how this works, there are tons of videos on it, but it is really cool technology. And so you're going to be able to apply visual constraints to it. So that's what you're seeing up at the top. We're choosing an area that we want to remain preserved. So we're saying that bracketed area is something that can't have material removed from it. You're also able to have these interactive controls, so we can click and drag this preserved region. You can have member size criteria. You choose how much of your part you want to have removed, and you can have symmetry control. So all this is great, but what's it actually doing? We're setting this up so that, let's say our part weighs 100 grams, and we want it to be reduced down to 50 grams. We can check that. Check these boxes to say that we want to reduce the mass by 50% and tell it which regions we want to preserve, and then it will iterate through and give us the best possible design to make that happen. Even better, we can then use simulation to verify that if we have loads of such and such an amount of weight, it's still going to be able to withhold and last the amount of time that we want. So not only are we providing a lighter part, we're going to be using less material, and we're going to still have the safest parts available. So some people that have seen this in the past probably have seen examples by someone like Airbus, who has been using really cool generative design to come up with shapes to provide very strong designs which never would have been thought of by humans. In fact, we probably wouldn't be able to create a lot of what they're working with these days. So next time you're up in the air, you can feel safe that, you know, the plane's lighter, but it's still just as strong. Another cool new simulation-esque technology here at Autodesk is NetFab. So NetFab is for designers and manufacturing professionals to do all sorts of cool things. Optimize your design, modify and prepare your geometry, process simulation. All of this is a lot of fun, fancy buzzwords, but really this is for simulating and getting the best and most accurate additive and subtractive manufacturing possible. So here on the next slide you can see topological optimization, where we're going through and having a lattice structure analyzed to see what could be removed and where the highest amounts of stress are. Hybrid additive and subtractive, cloud solving, machine integration, 3D printing. All these are cool, but my personal favorite is the hybrid additive subtractive workflows. So myself, I have a 3D printer sitting on the desk at my house next to me, and I can do a lot of cool stuff with it. I can 3D print some Yoda heads, and I can 3D print toys. I could, 3D print little things that break around the house and replace those, but it's not really super useful to have a 3D printer at home yet. But if we're able to take additive manufacturing like 3D printing and combine that with subtractive manufacturing like running a CNC machine and optimize the workflow between the two, I think we're really going to come up with some cool new designs that we wouldn't have had in the past. And the last thing that we want to talk about is winning more bids for you with simulation. Now, I don't really know what holding an iPad has to do with winning more bids for you, but I'm confident that it does. What I do know helps you is knowing the difference between optimization and validation. And this is probably a slide that you've seen before, and it's talking about the cost of optimization and the cost of validation. And this is really, where are you using simulation in your workflow process? If you're using this to validate your design, you're already costing yourself more money than you should. You can see that, I guess we're listing it in the hundreds there for design, engineering, prototyping. Then after you prototype it, you validate your design by physical testing as well as some analytical results. But if you're optimizing your design, you're using simulation earlier in the design cycle, and that's going to save you in the long run. A lot of people say that they don't have the resources available to make this happen, or that they don't have a finalized design, so why should they be analyzing it? Well, as you analyze it earlier, it means there's going to be less change between the prototyping and manufacturing stage and the engineering time. You know what's going to fail in your part, you're already accounting for that, and even at the design level, you're able to do some basic analyses to make sure that some simple changes won't have to be made further down the road. This oftentimes reduces the number of physical prototypes that you need to have created, as well as it can reduce the amount of time that an analyst has to be looking at the model. So we're always encouraging you to optimize your design by using simulation early and often. Now, as I am an Autodesk employee, I'm not allowed to give a presentation without mentioning Fusion 360. So many of you may have seen, Fusion 360 now offers a wide variety of simulation solutions. So these are based on the Nastran solver and allow for static stress, modal, and thermal stress, all of which they used to have, but it's now also offering structural buckling, shape optimization, like similar to the shape generation we talked about before, nonlinear static, and even event simulation. So all sorts of great technology being added there, but I do believe you'll probably have other webinars discussing that in more detail in the future. So getting back to what we were talking about, that's the Autodesk Simulation portfolio. So anything from structural mechanics to architectural design, fluid flow and heat transfer, to even the molding process and using advanced materials like composites, Autodesk has a solution to handle that. And this solution is purpose-built, it's flexible, it's integrated. So no matter if you're using Inventor or Fusion, SolidWorks, or I don't know, Pro-E if people still use that, or whatever people might be using, we're able to take that geometry, drop it into our simulation products, and then give you the optimized solution earlier in your design cycle to save you time and money. If you'd like some more resources based on what we talked about, as well as how to use the software, in addition to the social channels that we talked about earlier, I'd suggest that you check out the Autodesk Simulation blog, which has usually 1 or 2 blog posts come out a week about engineering, how to use the software, things like that. You can get your questions answered on the simulation forums. Each product has its own specific forum, and they're manned by a number of people here at Autodesk, as well as a lot of great community members who really know what they're doing. And you can always check out our learning and events. See if there's a webinar like this or a live event coming to an area close to you. So with that, let's open it up to some Q&A, and we'll see what kind of answers we can come up with.
All right, so if anyone has any questions and you haven't typed them out yet into the GoToWebinar panel, definitely do so. We've been monitoring that, or at least I've been monitoring that during the entire session. We've got a couple of questions here, and this first one here comes from Eric, and Eric's just asking what kind of sim tools or what sim tools are available using Fusion 360 versus Inventor. James, do you have?
All right, so we did look at a quick slide there, and I would say that well, Fusion obviously is changing much more quickly than a lot of the other products that we have, as it's being released and updated every 6 weeks or so. So that's pretty cool. And I do know that there's a big push on the simulation software there. I would say that the key analysis types that are different are that Fusion now has an event simulation for very quick, let's say, drops. So if you're going to be dropping your phone, you could add a velocity to your phone and have it hit off the floor, as well as some nonlinear statics that are involved there. So those are two key analysis types that Inventor doesn't have integrated, or Inventor Pro doesn't have integrated, but those are also available in something like Autodesk Simulation Mechanical.
Certainly, certainly. And I just want to reiterate here that those of you who do have suites and I guess some of the new subscription products, you do get a seat of Fusion 360 with a lot of those things. So you already have some of these tools available to you, and there is no necessarily monetary startup to get them, as you already own tools in some of these cases with Inventor Professional and Fusion 360. So definitely use the tools you already have. Dave Smith has a quick question here about CFD. Is Autodesk going to include discrete elements such as sand, gravel, seed grain, etc. in their CFD program? I don't know if you know about that.
So I can't really comment as to what they'll be adding to it. I know that they're constantly updating it, and we'll be having a new release of the software in a few months, I believe, but I don't really know the specifics as to if that's going to be added.
Definitely. So yeah, if I hear anything, Dave, or if I see anything once the new software comes out here in a couple of months, should be I'm assuming sometime April, May probably of this year, as they do every year. If I see anything, I'll definitely let you know. I'll make a note of that.
Another thing along those lines is if we don't have a feature that you're looking for, you can certainly go to the CFD Idea Station and make a request. So that's one of the places that our product management team goes to find the most requested features that they should be adding to the software, and they try and implement as many of those each release as possible.
Certainly, yeah, and I know for the Inventor team, I know that they're deeply looking into that, and they've included, I think, over 100 since the release of 2017 or 2016.3.
Yeah.
Or R3 till now. So definitely they are looking there, and that's where they're getting a lot of ideas for things to include in the software. So if you do have an idea and a bunch of people want to hop on that train, Autodesk will definitely try to accommodate if possible. We got another question here. Is there a way to simulate metal forging? For example, heating a metal bar and forcing it into a cast?
Forcing it. So metal forging is always one of those things that's a little bit tricky, because it involves a lot of analysis types and a lot of horsepower. So some very basic forging has been done, and it's typically done in a 2D fashion, where you could create the bar and then press it down and see how the material permanently deforms. But I would say more often than not, it's not going to do what you're looking for. Usually it's some complex forming that the software just isn't capable of doing, with a lot of restrictions on horsepower, contact elements, things like that.
Yeah, if you want to talk about that more, David, definitely shoot us a line, and we'll be more than happy to talk about any possibilities that there might be in regards to what you're trying to simulate and how you can get that possibly done. Now we've got a couple of questions here. Let's see. Is there any plan to integrate NetFab into Fusion 360?
So I'm not sure about that. Probably, because it seems like everything's going in there, but I guess I can't really comment on that anyways. But the Fusion team does a great job of updating us with roadmap blog posts and a constantly updating roadmap description as to what they're prioritizing into the product. So if you go to the Fusion 360 Product Center, you're going to be able to find the roadmap location where it tells you what they're planning coming out in the next release, the next coming months, as well as the next years. So they have an idea of where things are going. I would just say, personally, I wouldn't be surprised if I saw it in there, because why not?
Right, for sure. I'll give everyone, another 30 seconds or so here to type out any more last-minute questions. Again, I'd like to thank you, James, for being here today. Definitely a pleasure on our end. And I'm sure everyone enjoyed the the session and kind of learning about some of the industry trends moving forward.
Absolutely, and thanks for having me to present today. And again, feel free to reach out to me as well at james.herzing@autodesk.com with additional questions also.
If anyone does have any questions, definitely further, or things that might not even be related to the sim in general, definitely let us know in the survey afterwards. We'll be able to look at that and kind of answer some of those deeper questions. There are a couple of questions in the queue right now that I'll definitely answer through there, as they might take a little bit longer to answer. And I'll take care of that as they come. Again, I'd like to thank you, James, for being here. I'd like to thank everyone else for being here today. Next week, we're back with the 2017 release of Inventor. They did include a completely revamped presentation environment. Some of you may be using this already. Some may not have seen it already. I know that there's still a lot of people on 2016. I think this is one of the reasons to move to 2017 and forward. Really great environment. They definitely took care of some of the suggestions that users had, including finding stuff in the browser in presentation. That was like my favorite thing ever. Last minute question here, James, for you. This one came from Richard. Is there any added cost of dynamic fluid analysis? That's CFD only, I'm assuming, James?
Yeah, so if you go to the CFD Product Center, they're going to have a breakdown of the different products. I think that there's just one size fits all at this point, but that could be a lie. You'd have to check with the Product Center and check out the comparison chart to see which version your needs fall into.
Definitely, Richard. So it is part of like the CFD specific software, so it's not in something like Fusion or Inventor. But I'll go ahead and reach out to you once I get that information for you. So expect an email after this webcast. All right then. So I think that's it for today. We'll see you all next week for Yvonne Liu and her first AVA, which is going to be Inventor presentation. Definitely looking forward to it. And if you guys want to see James on another AVA, definitely let us know in the survey, and we'll definitely invite him back. It's definitely went really well for us. Wow, I'm using that word a lot. So we'll see you all next week. Thanks, James.
Thanks. Bye-bye.